Confidence intervals for proportions are tutorial. Remember the example that Jeff worked through in the lecture? He flipped the bottle cap 1,000 times and observed red 576 times. Your goal was to construct a confidence interval for the true but unknown probability p of observing red. The first method you learned was to substitute p hat for p to obtain the 95% confidence interval. We'll let p hat equal to 0.576. To obtain the critical value z from the standard normal distribution, we will use the Q-norm function, which stands for quantile normal. Recall that this value z from the standard normal distribution has probability above it of 0.025, or alpha over 2. In the Q-norm function, we specify the upper tail probability of 0.025, the mean and the variance of the standard normal distribution, and since this probability is in the upper tail, we need to specify lower tail equals to false. Now the margin of error is simply z times the square root of p hat times 1 minus p hat over n, and the confidence interval is p hat plus or minus the margin of error. We could alternatively use a function called binom.confint from the binom package. Let's install the package first by navigating to Packages and Data, Package Installer, and search for the package binom. Install the package and all of its dependencies, and then load it using the command library binom. Now the binom.confint function is available to us. We must specify the number of observed successes, or reds in our case, the number of trials, 1,000, and the confidence level of 0.95. The function also requires that we state which method we would like to use to calculate the confidence interval. We will use methods equal to asymptotic to obtain the desired results similar to above. The second method you learned was more conservative. It was achieved by letting p equal to a half in the confidence interval formula. We need only change our margin of error to reflect this. So we will redefine me to equal to z times the square root of a half times a half over 1,000. And again, our confidence interval is p hat plus or minus the new margin of error. Notice that this method yields a confidence interval that is wider than the first, but only ever so slightly. The reason for this is because p hat is very close to a half, or 0.5. So in this example, the two different methods produce very similar results. For practice, try constructing confidence intervals like the ones we just did, but at different confidence levels. What arguments would you need to change in Q-norm? And how would these different confidence levels change the width of the confidence intervals?